So, a couple things. First off, that eraser is horrible. You will still see warm-ups that are graded like this. Listen, if we've taught it, if we've gone over it, it's fair game. Especially when I say, hey, get out the stuff from, and I tell you exactly what day we did it. So keep your notes. When I ask you to write things down, make sure you have them. Fair enough? Okay, so go ahead, get out your packet. Go to page S9. So this is the problem set. So the first question says something to the effect, if I can find it. Let's see, where is it? Aha. The first question says 2x plus 7 equals 27, and 3x plus 1 equals 28. So let's talk very briefly about equations. Let's see if this helps. That might help. Let's try that one. Did that work? Or did that just make it too dark? Oh, now it's even glarier. I hate this glare. I don't know how to fix the glare. It bothers me. That does nothing. Okay. So what do we know about an equation? What does this actually mean? 2x plus 7 equals 27. What do we know about the equation? And I'm holding my hands like this for a reason. They have to be equal. What's on the left side is the same as the right side. So all of this 2x plus 7 is 27. This 3x plus 1 is 28. Everybody with me? So we know that one side is the other side. So if these are true, is 2x plus 7 equal to 3x plus 1? If these are true, is this true? Tell me why, tell me why not. So if 2x plus 7 equals 27, and 3x plus 1 is 28, are these true? Stephen? Okay, you're saying no. Why?
Because they don't equal the same.
Okay, so what is 2x plus 7?
27.
So you're telling me all of this is 27 because of this. Okay, what is this?
28.
All of this is 28 because here, 27 is not equal to 28. These are not equal because 27 does not equal 28. If we know an equation and we substitute in a solution, the solution has to balance both sides. And when I say balance, that means the right side better darn well be equal to the left side. Okay? Right now, we know this isn't balanced. 27 isn't the same as 28. Still with me? Okay? So let's try a basic one. Go to number 2. So you're looking at your problem set on S9. Number 2 says, is negative 5 a solution for 6x plus 5 equals 5x plus 8 plus 2x? So my question is, when it says, is negative 5 a solution? How do we show solutions in an equation? How would I show a solution to this equation? What would I say? How would I have an answer? And we just did this in the warm-up like number 2. What was my answer to that equation? What was the solution? So go back to number 2 in the warm-up. What was the answer? What did we say it was? Mackenzie, you have it? No, you didn't copy it down? Who copied down the answer to the warm-up? Go ahead.
Negative 80 over 9.
Was what?
A fraction.
It was, but did I just put negative 80 to ninths?
X equals.
Oh, I said x equals. So the solution to that equation was x equals the number. So they're saying, is negative 5 a solution? So for negative 5, it's saying is x equal to negative 5? That's what they're asking. Everybody with me? What do we have to do in order to figure out if that's true? If x equals negative 5, what operation or what mathematical term can I use with negative 5? It starts with an S. And I've said it multiple times already. It's what you have with Miss Armstrong. Is Miss Armstrong there today?
No.
So what do you have?
Substitute.
Oh, you have a substitute. So we're using substitution. Very good. So in order to check to see if this is true, we substitute in. We say 6, and we always use parentheses. Always. So it's 6 parentheses negative 5. What does that actually mean? What mathematical operation?
Multiply.
Multiply. Very good. So 6 times negative 5 plus 5 equals 5 times negative. That's a 2, Mr. H. That's not at all within the problem. Negative 5 plus 8 plus 2 times negative 5. Okay, so we've substituted in. Okay, now, this is a big, long problem, and I can understand why it would confuse some of us. So, remember how I've always said, hey, listen, their first step in equations is to do what? What is my first step always? Stephen. Not my first step. Cody.
Find the balance.
Find the balance point. The reason I find the balance point is to show myself a clear left side and a clear right side. So to help my mind, I'm just going to cover up half of it. I only want to see half of it. Because now my mind's like, oh, that's a much smaller problem. I can do that. Let's get our calculators. Let's do this portion of the problem. So physically, you're going to put in 6 times, that's what parentheses said, that's what Katie said, 6 times negative 5 plus 5. Tell me what that is. So raise your hands, we should all get it. I want to make sure that all of our hands are up and we've got this. Mackenzie, what'd you get? Negative 25. Zach, did you get that?
How do I put in negatives in that?
The bottom right corner has a negative. So we're going to do 6 times negative 5
Nice.
plus 5. Good question. Okay, we good there?
Yep.
So now we've done half the problem. Let's do the other half. Go ahead, I'm going to wait for you. You guys do this part. Come on, wait for hands up. Zach, go ahead.
Negative 27.
Okay, negative 27. So you put in your calculator 5 times negative 5 plus 8 plus 2 times negative 5, and we get negative 27. Oh, I didn't want to rip that. Gosh, darn it. So now we have negative 25 equals negative 27. Is x equals negative 5 a solution? McKenna, you're shaking your head no. Why? Because it's not equal to both sides. So negative 5 is not a solution. And notice how it says, hey, explain. This is the explanation here. Math is a universal language. That is the explanation. Everybody with me? Okay. On your own, you are doing number 3. It's asking, is negative, is it negative or is it positive? 1 6/10, I think. X equals 1 6/10. Does it satisfy it? That means, does it make it work? So x is 1 6/10. Does it make it work? For 6 minus 4x equals negative x divided by 4. Go ahead. Work on it on your own. See what you can come up with. Okay. So is there anybody who's confused about the substitution process? Allison, what'd you get for the left-hand side?
Negative 0.4. Negative 4/10.
Thank you. It's all right. Negative 4/10. Everybody with me there? Equals. Katie, did you get the right side? Well, let's do it. Get your calculator.
Negative 4/10.
Oh. So we get negative 4/10 for both. Now listen, wait a minute. Notice how this negative is right here and somebody's phone keeps going off. Please shut it off. Like I hear it's vibrating on the floor or on a desk. Please shut it off. So I have this here. This negative, which one does it go with? Cody?
The numerator?
Does it matter? It doesn't matter. It can go with the numerator, it can go with the denominator, but how many negatives are there? Just one. So don't put don't do negative 1 6/10 divided by negative 4. Just do negative 1 6/10 divided by 4, or 1 6/10 divided by negative 4. Only put it in there once. So is 1 6/10 a solution? Yeah, these are equal. So 1 6/10 is a solution. Now, is this newer for you? Yeah, it's newer. And I don't want to discount how much is going on through your brains because listen, you're 13, 14, 15. The world's crazy, especially right now. School's not the same way, but your calculator does it for you. This is easy. If you see this on your quiz, which is on December 15th, right? You should be like, woo, 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 I can do this one. Because these are easy, yes? Okay. Is it going to get harder? Oh, yeah. I would suggest getting out a separate piece of paper so that I can write this down. I am going to have an anchor chart. If you had me last year, one of the things that you would have noticed all throughout the room was the anchor charts. We had them all over the place in the back of the room because it was the important things that we needed to know. Already there's an anchor chart with an example of solving equations. Here's what we're going to do. This is steps to solve equations. This is going to be your money maker for the entire module 4. Once you learn to use these steps, you are going to be able to crush equations. Now, I'm going to write small because there's like 6 or 7 steps. You can use that whole paper because when you see an equation on the board, you're going to get out that piece of paper that says steps to solve equations. Okay? So step 1. This is not a universal step. This is a me step. What should we do? What should we always do? And everybody's hand should be up for this. What do I want you to do? Allison. Yeah, find the balance point. And I know that I don't write very neatly, but I'm going to really try. So I'm going to bring this up because I can, even though I've already stapled it. Perfect. I just ripped out staples. Nice. Cool. Good job, Mr. H. So here's our example. You don't have to copy this down because it's going to be hanging in the back of the room. Step 1, find the balance point. I certainly did that, right? Okay. Step 2 always happens next. It is distribute. But I'm going to put a comma. We don't always have to. We distribute only if needed. So let's look at our example. Did I need to distribute? Was there anything? What gives it away that I need to distribute? Cody.
A number touching parentheses.
Yeah, something smack dab up against the parentheses. It could be a number or a sign. There's no sign. Okay, good. Okay. Step 3. Here we go. Combine all like terms on the same sides. Okay. This is a little bit trickier because somebody in my first hour said, hey, Mr. H, what you do to one side, you have to do to the other. And I said, not always. And they got really confused. So I have a left side, I have a right side. That's why we have the balance point. I cover up my right side. I've got 3x plus 4 minus 2x. Here's how I like to describe this. 3 pounds plus $4 minus 2 pounds. My like terms are the pounds. I subtract 3x minus 2x and I only get 1 pound. Have I changed that side? Well, no. If I've told you 3 pounds minus 2 pounds, that is 1 pound. Nothing's changed on this side. So when we combine like terms on one side, we don't have to do inverses. We do exactly what it says. Could you combine variables? Yep. Can you combine constants? Yep. But you combine all things on one side. Did we do that? Yes. Questions there? Okay. Now we get to the trickier part. Step 4. Combine variables on opposite sides using inverses of addition and subtraction. And this is where a lot of people get confused, including teachers that I've worked with in the past. This is a confusing step. When I combine variables on opposite sides, we never divide, we never multiply. We are either adding or subtracting. So notice how we're here. I've got 1x plus 4 equals 5 minus 3x. It does not matter which side we move. I personally will always move my smaller variable. Negative 3 is smaller than 1. The inverse of negative 3 is positive 3. Why do I using an inverse? Because we're going to the other side. So I add 3 here, I add 3 to this side. That's me combining variables. Still with me? Okay. Step 5. Very similar. The only thing that I'm going to change is the word variables. Combine constants on opposite sides using inverse operations of addition and subtraction. And we're going to do a bunch of examples. We've still got 10 minutes. We're going to get hopefully 2 or 3 examples. So I combined my 4 and 5. Why didn't I move the 5 this way? Because the goal is to get the variable by itself. So I had to subtract 4 to both sides. Last step. It's going to be isolate, which means get it by itself. The variable using inverse operations of multiplication or division. Once you're done copying that down, go to page S12. And we're going to do an example straight from number 1. So number 1 says x plus 4 plus 3x equals 72. This is not a new equation. I would expect you to know how to solve this already. So let's use our anchor chart and go exactly with our steps. Step 1, find the balance point. Step 2, distribute if needed. I do not need to. How do I know? There's no parentheses. Step 3, combine all like terms on the same side. Which side has like terms? The left or the right side? Come on, raise hands, raise hands, raise hands. Zach.
The left side,
The left side. What are my like terms on this side?
x,
And? So this x and
positive x,
positive x and what else? What's its like term? So x with what else?
negative x.
Not quite. Katie?
Positive 3x.
It's a positive 3x. The x's are the like terms, you're right, but this x and this positive 3x are like terms. Now, how many x's do I have here, Jupiter?
2.
Right here.
1.
1. When the variable does not have a coefficient, it's 1. So because we're doing it on the same side, we just do what it says. 1x plus 3x is 4x. Plus 4 equals 72. So I've now done step 3. Step 4, combine variables on opposite sides. Do I have another x on this side? Okay, then we're done with step 4. Step 5, combine constants on opposite sides. Do I want to move the 4 to the 72 or the 72 towards the 4? What do we think, Katie?
4 to the 72.
Yeah, we want to get everything away from the variable. So we're using inverse operations of addition and subtraction. This is addition, so we have to use?
Subtraction.
Very good. And we do that to both sides. That leaves me 4x equals 68. Last step, isolate the variable using inverse operations of multiplication and division. This is multiplication, so I need to divide. I'm going to divide both sides by 4. That leaves me with x equals, and I think it's 17, but double check my work, please. I'm just making stuff up. Is it 17? Oh. Winning. Okay, questions on that one? Okay, we got one more to do. We've got 5 minutes left in class. Do not leave until we're done. So doing number 3. It is 1/2 x plus 10 equals 1/4 x plus 54. Again, we're going to follow the steps. So here's what I want. I'm going to say step 1. You're going to say, yes, I need to do it. No, I do not. So just yes or no. Step 1.
Yes.
Yeah.
Always. Find the balance point. Always. Step 2.
No.
Cody's the only one who said no, so let's try this again. Step 2.
No.
No.
There's no parentheses. There's no distributing. Cody's not allowed to answer. Step 3. Combine all like terms on the same side. So once again, step 3. No. So on this left side, there's an x, which is a variable, and a constant. I can't combine those. On this side, there's an x and there's a constant. I can't combine those. Step 4, combine variables on opposite sides.
Yes.
Absolutely. Katie, which variable do you want to combine?
1/2 x and then 1/4 x.
Okay, so you want to combine these. Which one do you want to move? 1/4 or 1/2?
1/2.
Okay, so we're using it with addition or subtraction. So what do I need to do with 1/2 of an x?
Combined.
So combine variables on opposite sides using inverses of addition or subtraction. So this is a positive 1/2.
So subtract.
Very good. So we're going to subtract. And I'm going to subtract that from both sides. Let's get our calculators. You should know that additive inverse says 1/2 minus 1/2 is 0. That leaves me with 10 equals. Put into your calculator 1 divided by 4 minus 1 divided by 2. Press enter. Tell me what we get. Katie?
Negative 25.
Are there decimals in this problem?
No, so
Remember, if we get a decimal, let's change it to a fraction.
-1/4.
-1/4 x. The 54 comes down. Okay, so we combined variables. Now we're combining constants using addition and subtraction. So again, I ask, Mackenzie, do I want to move the 10 this way or the 54 this way? So do I want things to come closer to the x or farther away from the x? Yeah, so we're going to move the 54. Very good. It's positive, so what do? Excellent. So we subtract 54 from both sides. That leaves me all of this coming down. So -1/4 x equals -44. Hey, this is like our warm-up. I've got a fraction. What did we say we had to do to isolate that variable when there's a fraction? Come on, Cody.
Multiply by the reciprocal.
Here, 5. Multiply by the reciprocal. The reciprocal is it flipped over, which is -4/1. That is the multiplicative inverse property. That leaves me with just 1x equals -4 times -44. Somebody should help me with that. I have no idea what it is. It's going to be 6, 1, negative, or positive 176. Is that right? Can we do that? I don't know. I'm asking.
176.
Woo! These rules are going to be imperative that you know. It will get easier the more that we do. Now listen, is this fair game for a warm-up? Absolutely. Is this fair game? Not so much. Will you see this on Monday? Yes, you will, but it will be a bonus one. You will still have questions about exponents. You will still have problems about scientific notation. You will absolutely need to know how to solve equations. Questions. There are 2 videos already in your Google Classroom for lessons 5 and 6. We start getting into tougher equations. You need to watch them. There will also be this live video if you'd like to rewrite the rules. Good job today, kiddos.